As sunlight falls on the pole, the beam makes an angle with the pole and the shadow. As the sun changes its position, the angle changes, and the length of the shadow changes according to the angle made by the sun. How can we find the length of the shadow without actually measuring it? We can find the length of the shadow if we have the values of the trigonometric ratios of the respective angles. So how can we find the trigonometric ratios of these angles? Using the properties of triangles, we can find the values of trigonometric ratios for some specific angles such as 0, 30, 45, 60, and 90 degrees. Let's see how. What type of triangle is this? Yes, it is an isosceles right-angled triangle. In the triangle, sides AB and BC are congruent, and angle B is equal to 90 degrees. What can you say about angle A and angle C? According to the isosceles triangle angles theorem, the angles opposite to the equal sides are equal. Thus, angle A is equal to angle C. Since the sum of the three angles in a triangle is 180 degrees, angles A and C are each equal to 45 degrees. By applying Pythagoras' theorem, we get AC is equal to the square root of 2 times BC. Since the sine of angle A is opposite side over hypotenuse, the value of sine 45 degrees is equal to 1 over the square root of 2. The cosine of angle A is adjacent side over hypotenuse. Therefore, the value of cosine 45 degrees is equal to 1 over the square root of 2. The tangent of angle A, which is BC over AB, is equal to BC over BC. Remember, it's an isosceles triangle and AB is equal to BC. So the value of tan 45 degrees is equal to 1. Thus, we get the values of all trigonometric ratios for the angle 45 degrees. Consider an equilateral triangle. What can you say about angles in an equilateral triangle? In an equilateral triangle, all three angles are congruent, and each is equal to 60 degrees, since the sum of the three angles in a triangle is 180 degrees. Let's draw a perpendicular bisector AD as shown here. What can you say about this perpendicular bisector AD in this triangle? In an equilateral triangle, the median, altitude, perpendicular bisector and the angle bisector are the same, corresponding to a vertex and its opposite side. Thus, the line segment AD acts as an angle bisector and also as a median. By applying Pythagoras' theorem, we get side AD is equal to A times square root of 3 over 2. Since the sine of angle B is AD over AB, the value of sine 60 degrees is equal to the square root of 3 over 2, and the value of sine 30 degrees is equal to 1 over 2. Similarly, the value of cosine 60 degrees is equal to 1 over 2, and the value of cosine 30 degrees is equal to the square root of 3 over 2. Since the tangent of angle B is AD over BD, the value of tan 60 degrees is equal to the square root of 3. And the value of tan 30 degrees is equal to 1 over the square root of 3. Thus, we get the values of all trigonometric ratios for angles 60 and 30 degrees. Let's look at the values of the trigonometric ratios for angles 0 and 90 degrees. Observe this figure. As the angle A becomes 0, the hypotenuse AC becomes AB, and the side BC becomes 0. Since sine A is equal to BC over AC, the value of sine 0 degrees is equal to 0. Correspondingly, the value of cosine 0 degrees is equal to 1. Since tan A is equal to sine A over cos A, the value of tan 0 degrees is equal to 0 over 1, that is, 0. Thus, we get the values of all trigonometric ratios for the angle 0 degrees. Observe this figure. As the angle A becomes 90 degrees, the hypotenuse AC becomes BC and the side AB becomes 0. Since sine A is equal to BC over AC, the value of sine 90 degrees is equal to 1. Similarly, the value of cosine 90 degrees is equal to 0. Since tan A is equal to sine A over cos A, the value of tan 90 degrees is equal to 1 over 0, which is not defined. As you can see, all the values of trigonometric ratios for the angles 0, 30, 45, 60 and 90 degrees are shown here. How do you remember these values? There is an easy way to fill in this table. Let's see how it works. To write the values of trigonometric ratios of these angles, first write the numbers 0, 1, 2, 3 and 4 in order below the angles. Divide each number by 4. Find the square roots of these values. These are the sine values for the respective angles. Write the same values in reverse order to get the cosine values. Divide the sine values by the cosine values to get the tangent values.